Okay, so what we're going to look at in this lesson is the idea of what's known as a scatter graph. Scatter graph or scatter diagram. It comes under a few different names. So if we have a look here, so what we have is we have data, and this would be an example of what's known as bivariate data. Okay, so you have two sets of data. So one set of data looks at what's known as average temperature, so just temperature, let's say, out and about. And then the other set of data is the number of ice creams sold. So we have the average temperature and the number of ice creams sold. Now what we can do is we can take this data and we can represent it like this, which is what's known as scatter graph. So if we think about graphs in general, so what you have, you have an x-axis along the bottom, which in this case represents temperature or average daytime temperature. So this data here, the temperature data, this is all represented on the x-axis. Then you have number of ice creams sold. So again, this is what's known as the y-axis. So you have the x-axis along the horizontal axis and the y-axis, which is the vertical axis. So the data that you have then on the y-axis is the actual number, the numbers of ice creams sold. Now what we can do is we can pair up this data. So for example, we could create a number of XY points like so. So let's say this first one here would be 10, 1. Okay, so this second pair of data would be the point 12, 5, and so on. You can do the whole lot for each pair of data and have an X and Y. So you're going to have your X value, your X, and then your Y value. You have your X and your Y value. And then what you can do then is you can plot these on the graph. So if we have a look then, so we can see here, so let's say, so this is 0.1, 10, 1. So again, you can see we go 10 on, so this is 0.1. Okay, then we have this next point, 0.2. So again, the x-axis is the value is 12, and the y-axis the value is 5. So that's this one here. So it's the x just below that dot that I'm drawn. We have this one here. So again, 6. So that's the x-axis is 16, the y-axis is 20. So 16, 20. That would be this one here. Okay, and so on and so forth. So they're all basically plotted along like this. And this, as I was saying, is what's known as a scatter graph. Now, what this can be used to do is it can show the relationship between two sets of data. So in this case, what it's used to do is to show what's known as a correlation, if there's a correlation. And correlation just means like relationship. So it's the relationship between the sets of data. So what we're trying to figure out here is there a correlation between x, so for example x, so it's temperature, and y, which in this case is ice cream sold. Okay, so that should be is there, not if there. So is there a correlation between X and Y? Or in this case, like X and Y can be anything, but in this case we're talking about temperature, the average temperature during the day and the number of ice creams sold. So what we do is we use this, we plot all of these bivariate data points on a graph, on an X and Y graph. We label our, so for example, X is the average temperature and Y is the number of ice creams sold. So we can see here, as we move from left to right, on the X-axis, the temperature is going up, okay? So in relation to temperature going up, what's happening to the y-axis? Is it going up? Is it going down? Is it staying level? What exactly is happening? And this is what we mean by correlation. So we're trying to figure out there's different types of correlation, but we're trying to figure out what are the types of correlation that we're dealing with here, or is there a correlation basically? So we can see here, roughly speaking, we have some kind of a correlation going on. So if we think about this, so roughly speaking, if we were to draw a line, let's say, between all these points, we have some kind of a correlation. So what we can see here is as we move across, okay, as we move across, this y value goes up. Okay, as you move across, the y value goes up. So as the temperature increases, the y value increases as well. So what we could say with this one is that we have what's known as a positive correlation. So what we're able to say then as well is that there is some kind of relationship between the temperature and the number of ice creams sold. So it appears to be that as the temperature goes up, the number of ice cream sales goes up as well. They relate to each other. So they're two separate sets of data, but they appear to be influencing each other or related to each other. And we can see this, and when we look at what's known as, when we take this data, it's like in a table, it's in table form here, and we put it into what's known as a scatter graph that looks like this. And another way to think about it as well is that we have, so if we look here, we have like a straight line. So this is a straight line. Now, the more these points, so we have all of these individual points here, and we can see some of them are under the line, some of them are on the line. Okay, so we can see all these points here. So some of them are below, some of them are above, and some of them are on the line. Now, what we say is that the closer the points are to falling on a straight line, the stronger the correlation. So we have a positive correlation here, but if the points, let's say if all of these points lay exactly on this straight line, then we would say that there is a very, very strong positive correlation between this variable, which is the average daytime temperature, and this variable, which is the number of ice creams sold. So the more that these points fall closer to this straight line, the stronger the correlation is between the two variables that you're looking at. So if we were to just kind of think about this as well, and I just want to introduce these and we'll look at them in a little bit more detail as we go along. So imagine we have a graph like this. So we have, I'm just going to draw two axes. Okay, so imagine this is just a general graph, just in general. So again, remember this is your x-axis and this is your y-axis. So if we have, let's say, points that are falling like this, in this case, what we're saying is that, I'll just rub these out here. In the case of, let's say, the red axis that I'm putting in here, this is what's known as so this is equal to, so this kind of arrangement here is what's known as a positive correlation. Okay, so that's it's a positive correlation. Okay, so if you were to get the slope of it, it would be positive. If you were to look at something like this, so imagine you had this set of data and it was going something like this. So this is again like just our green x's. So what we're saying is that this is a negative correlation. Okay, so a negative correlation. So as x increases, y decreases. Okay, with the positive correlation, as x increases, y increases. If we take something like this, so imagine like this is we plot values that are like this. So we can see, let's say in this case where we have, like if we just focus on the blue x's, if the data is showing up like this, it's showing up all over the place, then there's no correlation. Okay, so there's no correlation. So these are the different, so you can have a positive correlation where it's going like, so in a positive correlation is like this, if we're to do the red. So just imagine we have a red line, so something like this. So this is a positive correlation. If we were to look at the green, for example, this here, this is a negative correlation, and then the blue, then like it's not even possible to try and draw a line through this, okay, because the points are just scattered all over the place, so therefore there's no correlation. Now we can have then, you can have weak and strong positive correlations and weak and strong negative correlations, and we'll talk a bit more about that in the next lesson. But basically, just generally what that means, like the way that it's arranged like this would be an example. In the case of the greens here, that's a very, very strong negative correlation because the green points are all very close. They're nearly all on the line. Now, if we had something like, let's say, if you had, I'll just do a different shade of green. So imagine if you had something like this. Okay, so this here still forms a correlation. There's a negative correlation, but it's a weak negative correlation. So again, just in relation to the negative correlations, you can have strong and then you can have weak. Okay, same thing with the positive correlations as well. So this here would be an example of a strong positive correlation, but if I had something like this, let's say, so I had points that there was a correlation between them, but they're kind of just not all exactly on the line, then this is what will be considered a weak positive correlation. So again, these can be strong and they can be weak. So that's just a general introduction to what we mean by scatter graphs. So it's just another way to represent data, and this idea of like in relation to a correlation. So what you're saying, what you're trying to see is there a relationship between the two sets of data, like as one increases, what happens to the other, etc., etc. And scatter graphs as these here are perfect for doing that, for carrying out that kind of analysis. So that's the idea of scatter graphs. So hopefully that makes sense. Just as a quick introduction, and again, like we'll go through examples and we'll talk about it a little bit more in a little bit more detail as well. But the idea is that you can construct a scatter graph if you're given a set of data, but then also that you can interpret the what it's actually telling you here. So if we think about this one here, when we're looking at very like concrete examples, we can see that as the temperature goes up, the number of ice creams sold go up as well. And there's loads of other different types of correlations that you could look at as well in relation to that you could plot on a scatter graph as well. So you could think about things like number of hours spent studying a subject and the grade achieved on the subject as well. So that would definitely follow a very strong positive correlation in relation to that. Well, depending on the study put in, but they're the types of things, and the types of data are bivariate data. So bi meaning two and variate meaning two sets of data points that you can look at and you can plot in this way. So again, it's just statistics. It's about taking data and representing the data and then trying to figure out what does that tell us about the data that we're looking at. Okay, so hopefully as an introduction that makes sense, but we'll go through other examples and hopefully it'll become a little bit more clear if it's not making sense right now. Okay, so thank you for listening.